In the past few decades, we've come to realize that our view of the solar system was missing 90% of the picture.
25 years ago, we thought that Pluto was the edge of at least the planets in our solar system. But now we know that there are many more objects like Pluto out there. So not only has the edge of the solar system moved out, but we've become much more aware of how much more we have to learn.
Our newest eyes in the sky peer into these most distant regions of our cosmic backyard.
We are just learning about the vast array of objects in the outer part of our solar system. As our technology has increased, we keep discovering more and more exotic objects, and our picture of what the solar system really is has changed as a result of our ability to improve our eyes.
But it's very old tech that's actually taking us to the very edge. When NASA launched Voyager 1 in 1977, they thought it might work for 5 years. 37 years later, the little space probe that could is still sending us mind-boggling information. In August of 2012, it was just over 11 billion miles from Earth. It had left the heliosphere and entered the utterly mysterious heliopause, the junction between the sun's atmosphere and interstellar space.
That heliopause is sort of where those two boundaries meet. It's sort of where our neighborhood kind of stops and sort of the general neighborhood begins.
I was excited when the news came back that Voyager was in the heliopause. This is an entire region of the solar system about which we know almost nothing. And for the first time in human history, we had a robot probe sitting in the middle of it, measuring what was going on around it. It was groundbreaking.
For the first time, we can say, even in a limited extent, that humanity is an interstellar species. We are now out between the stars.
When our game little interstellar probe took a look back at the solar system, it had quite a surprise for us. We had thought the heliosphere was shaped a bit like a comet, with a giant tail extending back hundreds of billions of miles. But Voyager found something new and extraordinary. It didn't find a comet-shaped heliosphere with a giant tail. It found a crescent moon shape with two short tails.
It's a really important observation because it teaches us something new. It teaches us what the fundamental shape of the heliosphere is. I mean, a long time ago, we just had the simplest picture, but now we have some detail. We know it's got some structure, and we can start with that and push forward and really begin a deep understanding of the region around the sun.
The tails are actually jets of energized solar wind.
What causes these jets is fundamentally the tension or the interaction between the background magnetic field of the galaxy and those streaming fast charged particles that are coming from the sun.
Voyager also sent back shocking news about the very edge of the sun's influence.
The heliopause may not be a clear barrier.
It's not just a hard edge. It's not just something really sharp. It's actually sort of a fuzzy extended region. It's hundreds of millions of miles wide.
And right in the middle, Voyager detected something truly weird. A sphere of giant magnetic bubbles.
We expected that the solar magnetic field would just sort of disperse at that point. But that's not really what happened. What they found is that the magnetic field lines from the sun have tangled up, creating sort of a frothy, foamy magnetic structure with bubbles. That was quite a surprise and a very exciting one.
As the sun's magnetic field ripples out, it twists and tangles. The lines crisscross and reconnect, forming giant magnetic bubbles.
Each foamy sphere bubble thing is about 100 million miles across, which is tremendous. That's the distance from the Earth to the sun. And there are thousands of these surrounding the solar system.
No one is sure what these magnetic bubbles do, but it's possible that this cosmic bubble wrap is the first line of defense against galactic radiation, helping protect the solar system from the cosmic onslaught.
Think about how much technology has changed since Voyager was launched and today. No one had phones in their pockets. I mean, no one could even make long-distance phone calls across the ocean without it being a tremendous ordeal. But yet, with this old technology, we're now learning about the very edge of our solar system. Just imagine what we're going to learn over the next 50 years.
Is now beyond the heliopause, traveling through interstellar space. But has it really left the solar system?
Not really. There is still plenty of solar system out there for Voyager to pass through. And it will still be going for many centuries, many millennia, before it leaves the solar system proper.
It's outside the sun's atmosphere, but not beyond the sun's gravity.
As we go out, we run into the Kuiper Belt, beyond Pluto's orbit, right? This is very, very far away. And then even beyond that, we have the heliopause, the area of the sun's magnetic field. So you might think that you're at the end of the solar system. But guess what? There's still stuff out there that's gravitationally bound to our solar system.
Every once in a while, something sends that stuff hurtling toward the sun. And sometimes, Earth gets in the way.